All right, here is the last of the inequality series. We're still solving. Something's different about these ones now, and we're going to encounter it together. So you're still going to undo. So this is negative 5x plus 10 is less than 50. So we're adding 10, so let's subtract 10. We're left with negative 5x plus 0, so we're not going to write it, is less than 40. So now it's negative 5 times x. Let's undo that by dividing by negative 5. And so we get negative 5 divided by negative 5 is 1. So we're left with x is less than 40 divided by negative 5 is negative 8. So let's try that out. Think of a number that is less than negative 8, so meaning it's more negative. So I think of negative 10. So let's try that out. If x is negative 10, negative 5 times negative 10 is a positive 50. 50 plus 10 is 60. 60 is less than 50. What we created does not make sense, okay? So what we have to do now is reconfigure this, because this could be true, because if we flip the sign, right, 60 is greater than 50. So somewhere in here, when we are dividing or multiplying by a negative number at this point, we need a sign flip. So let me show you what that could really look like, okay? So if I'm just going to rewrite it here and then get rid of the other card, negative 5x plus 10 is less than 50. So let's try this again. It's still going to be subtract 10. So it's negative 5x is less than 40. When we divide right here, the clincher is we are dividing by a negative. The moment you multiply or divide by a negative number, when in your inequalities, you must flip the sign, okay? So you must flip that sign. My shorthand's probably getting a little crazy, but hopefully you followed along to what I said. If you're multiplying or dividing by a negative number across the inequality, so from one side to the other, you must flip your sign. And so this part is still the same as we knew. Negative 5 divided by negative 5 is 1, so that's x. It's 40 divided by negative 5, that's still negative 8, but we must flip our sign. This only works if x is greater than the value of negative 8. So let's try that. Give me a number bigger than negative 8, so that's one that is less negative. So let's plug in negative 5. So negative 5 for x, negative 5 times negative 5 is a positive 25. 25 plus 10 is 35, and 35 is in fact less than 50. So now we create a true statement, okay? So the only new twist and turn is what happens when you multiply or divide by a negative. You still have to plot it. So we're saying that this works for when x is greater than negative 8. Okay, that's what makes this scenario true. So then it's a number line that you create. Mine happened to be created in this way. So this is negative 5. So maybe negative 8 is right here. So I need to put an open circle at negative 8. I'm not going to close it in. And this is for values that are greater than negative 8, so less negative. So I'm going more positive, right? And that is how you plot this start to finish. So now that we've done that and learned a new rule, here's the last one of this video. We're still going to add 12 because we are undoing. We have negative 2x is greater than or equal to 26. We're going to divide both sides by negative 2 because that's negative 2 times x. We're left with x and a negative 13. Because we divided by a negative, we must flip this sign. So it becomes, instead of greater than or equal to, becomes less than or equal to. Okay, so let's do a quick check. If x is less than or equal to negative 13, I'm just going to rewrite that equation. You don't see what I'm doing, but you'll see it in a minute. So let's just check this, right? This is where we did a sign flip. So give me a number that is less than negative 13, so more negative. Well, maybe we think of negative 15. So that'd be negative 2 times negative 15. Subtract 12. Let's see if that is greater than or equal to 14, right? Going back into the original equation. So negative 2 times negative 15 is a positive 30. We're going to subtract 12 and ask ourselves, is this greater than 14? 30 subtract 12 is 18, and 18 is in fact greater than 14. And it didn't have to be also equal to, that was an or scenario. So by sign flipping our final inequality, we were able to create the original inequality to prove it to be true with these values. And so when we go to plot x is less than or equal to negative 13, here's a number line I created. You will have to create your own number line. And here is negative 5, negative 10, negative 15. So 2 and 12 and a half. So maybe right about here is a negative 13. And this is less than or equal to. So at the negative 13 mark, I'm going to circle it and color it in because it includes that value. And this is for all values of x that are even more negative than 13. So I draw an arrow to the left to represent that any value at negative 13 and smaller will make the original equation true. So remember, when you are multiplying or dividing a negative across an inequality sign, so from one side of the inequality to the other, you must always flip your sign.